today we're going to take a look at the rest of 7.4 that we didn't finish last time. 7.4 is about percents and interest, and the part that we had left was the part about interest. So that's where we're going to jump into. So taking a look at this, we're going to talk about interest. Interest is simply the amount of money that you pay or that you earn on your money. So if you're putting the money in the bank, the interest is the amount of money you earn on your money. If you're borrowing money from the bank, the interest is the amount that you pay for the luxury of having that money to be borrowed. The principal is the original amount that you either loaned, right, you got as a loan, or that you put into the bank. That's your principal. And then your interest rate is the percent that's used to determine how much interest you get. There's two different kinds of interest. One is simple interest, and there's two formulas for that. If you'll notice, they're exactly the same formula. The easiest way to probably see that is that the second one, if you distribute the P for principal through that formula, you'll actually end up with the first one, right? Or if you take the first one and you were to factor a P out, this would factor out P divided by P is 1, PRT divided by P would be RT. You have the second formula. Now, depending on what kind of information that you're being given, might depend on which one you want to use in a given moment. That's just kind of how it works. So the P in this problem is principal. The R is your interest rate as a number. So you have to turn it back into a numerical form, not a percent form. And then T is the amount of time in years. And that's really important because if you're given 18 months and you put in 18, it's not going to give you the right value. That's going to give you some value 18 years from now, not 18 months from now. So if you were given 18 months, what would be the correct T value? 1.5, that's a year and a half. So keep that in mind because that's sometimes a slip up. And then the other one right here is the compound interest formula. And I put a note on here that this looks different than the one in your book. The one that I want you to be most familiar with is the one that is most commonly used. And it's not the one your book presents. This is the one you've probably seen before. It's the one that most textbooks use. And it's the one that works most generally given the information you have. It's more general than what your book does. Okay, so you see R in there, just like the interest rate up here, the percent as a decimal instead of as a number or the percent form. P is still the principal. T is still the time in years. This N right here, though, is something different. N in this problem is the number of compoundings per year. So if you talk about something compounding quarterly, what does quarter mean? 4. Then N would be 4 for 4 times a year. Notice the N's in 2 locations. So you make sure you put the N in those 2 locations if you're using this formula. If you were talking about something that compounded daily, what number would you use? 365, and we're just going to assume it's not leap year. 365. What if it compounded monthly? 12. Weekly? 52. You weren't sure on the weeks. Okay, 52. Occasionally you'll hear the phrase bi-weekly or biannually. So when you hear the phrase bi, it means every 2. So biannually would mean every 2 weeks. So people are paid their income that way. My husband's income is paid that way. He's paid every 2 weeks, which means twice a year we have a bonus month. We get 3 paychecks in a month. That's really exciting, right? You get a whole other paycheck that month. But of course, in kind of a year, it works out. Most months you don't. So every 2 is what that means. So if you talk about something that was biannually, that means every 2 years, which would mean T is actually 1/2. You don't see that very often. But if you talk about semi-annually, because most of you are women, so you know what a semi-annual sale is, right? Semi-annual sale, JCPenney, Dillard's, things like that. It means twice a year. All right, so we're going to have different phrases used like that. You need to be familiar with what they're talking about. So let's take a look at an example. All right, a company is expanding its line to include more products. To do so, it borrows $320,000 at 13.5% annual simple interest for a period of 18 months. How much interest must the company pay? A lot. That's exactly right, Jessica. A lot. All right, so the first thing you have to decide is which interest formula did it describe? simple. And in fact, it used the word, didn't it? So please do not be afraid to underline keywords in what you're talking about. It will help you pick the right piece of information for what you're working with. We need a simple interest formula. And you can pick either one of them that you like. I tend to use the one that has the parentheses in it myself. But if you want to pick the other one, I'm okay with that. Now, what this formula will do, though, is this formula does not specifically give us interest from the get-go. It gives us the new amount that the company's going to owe. That's what it's going to give us. Okay? So, we're going to have to do one more step at the end to actually get the answer it was asking. But, at the beginning, this is where we're starting, simple interest formula. So let's fill in the pieces that we know. What do we know here? Okay, we know the percent. That's this 13.5 right here. If I write this down, what letter is this going to correspond to? It's not P. R. It's corresponding to R for interest rate. What value would R be? 0.135. We have to turn that percent, which we learned last time how to do that, back into a decimal. So that's my R value. What else do you know? What they started with. How much did they start by loaning out? $320,000. What information does that give you? That's the principal P, right? So this tells us that P is going to equal a lot. $320,000. What else information are we given? 18. The 18 months. What does the 18 months tell us? That tells us the time, and T is equal to 1.5 years, or 1.5, right? Okay, in fact, all three of those pieces of information give me everything I need on the right-hand side of the equation, doesn't it? Definitely. So I can fill them in. So P is 320,000. 1 plus. R is 0.135. And T is 1.5. Written something like this. Now, some of your calculators will let you enter that in just straight away like it is. If you do, be careful in the parentheses. Okay, so don't close a parenthesis before you need to, that kind of stuff. Others of you maybe don't have calculators that can handle this quite so effectively straight away. If that's you, you're going to work from the inside out. So you can take the middle part and you can multiply those two together, right? Inside out, parentheses, order of operations. You start with the very most inside, multiply that. And then hit plus 1, moves you out. And then hit times 320,000, moves you out one more time. Okay, inside out. Or if your calculator can handle it, you can do it all at once. Either way you do it, you're going to end up with the same value. What value do you end up with? It better be more than 320,000. Okay. 384. What's next? 800. 800 is it even? Yes. Okay. $384,800. And so we need to take that value then and do what? What is that value? What do we just find? How much they have to pay back. That's what we found out. That's what we found. Make sense? They borrowed $320, they owe back $384,800. Okay, so what we want to find then is how much interest, that is how much extra do we have to pay for the luxury of having borrowed the money, and how will we do that? Right, so my interest is actually found by taking the $384,800 minus the $320, and what will I get? $64,800 with a dollar sign. Time is always in years. No matter how it's given to you, start with times in years. Okay. All right. So do please make sure you're giving the answer it's asking for, because it could have very well asked you how much money do they need to pay back, right? And if they had, you wouldn't have even needed to do this next part, so don't do it. Make sure you're answering the question that's really being asked. All right, example 10. Johnny and Caroline have 3 savings plans which accumulated to the following interest for 1 year. A passbook account made $53.90 on a principal of $980. A CD made $52.20 on a principal of $600. and a money market made $158.40 on a principal of $1,200. Which account paid the best annual interest rate for 1 year? This would be good to know, right? If you're being given some different options. And so what we're going to do is we're going to find the interest rate. So how do we find the interest rate? Well, what we're going to do is we're going to figure out how much, what percent they made out of what they were investing. So let's take part A, or I call it 1. Let's start with that. All right, so the passbook account, it made $53.90. And we invested $980 for that to happen, right? So if you were to take the $53.90 and divide by $980, and then you would multiply by 100% to turn it into a percent, you would be able to find the percent that you made on your money in a given year. So we're going to divide $53.90 by $980, and then multiply by 100. What percent is this? Thank you. 5.5%. Did everybody get that when they did their calculator? So this is 5.5% for the passbook. What do we do for the CD? Same thing. Yeah. 5520 over 600. You should be expecting this number to be what? Higher or lower than the last one? Higher. Why? Yeah, the denominator basically is much smaller than the one before, but the numerators are very close, aren't they? They're almost the same. Really, they're about $50. But the denominator is considerably smaller on this one. All right, so if you divide this, what do you get? 9.2%. And it's larger. One of those things you should be thinking as you're working through a problem, making sure the answers make sense with what you were expecting. Don't let your calculator mess up the problem, okay? All right, third one. What am I going to do? Somebody tell me what to write down. Okay, so the amount that we made divided by the amount we invested times 100%. 13.2%. Now, we've done all the work for the problem. We still haven't answered the question. Again, go back, make sure you're answering what was asked. The question said, which account paid the best annual interest rate for 1 year? The money market did. So you need all the work because the work supports why you believe it's the money market. But the answer is, in fact, that it is the money market that paid the best amount of money. Now, let's just take for a minute and change the order, or change the description of this, so you can think about what would happen if this problem had been presented a little differently. Let's say instead of a passbook account, a CD, and a money market, i.e. things that are all making us money, we had a car loan, and we had a credit card, and we had a student loan. These were all loans instead. Okay, things we're paying money on instead of actually earning money on. If that were the case, which account would we be most likely to like? The 5.5, right? The one that's the less interest rate. So it depends on what you're actually doing with the problem as to which interest rate is the best interest rate for you. Does that make sense? Okay. And we're going to do another problem that doesn't look exactly like interest, but I throw it in here because I want you to understand that it works the same way as the problems we're looking at that do actually have physically interest involved. All right, if a publishing company signed an agreement to allow a textbook, first edition 500 pages, to expand over several editions to 1,000 pages. So you understand what's happening? Every time the textbook grows in this particular, whatever kind of book it is, it's going to get a little bit bigger. And it tells you it's going to get 10% bigger each time, right? How many editions could be published before it reached its limit? That is, before it maxed out about 1,000 pages. All right, so taking a look at this problem, what are we going to do? What can I do? Well, my first edition of the book, I know has 500 pages. How can I figure out what the next addition would be? Times what? Okay, that won't give it to me directly. That will just give me the increase. Okay, so one way to do it for the second addition directly would be to take that 500 pages and multiply it by 1.1. Some of you know what the 1.1 is representing, and others you were looking at and go, where did 1.1 come from? Well, it actually came from this. This is actually 1 plus 10%, and that 1 there is representing the next addition, one additional addition, one increase of 2%. Looks a lot like a simple interest formula, doesn't it? It should. The simple interest formula took the rate, that's my 10% here. This was a number of years, and it's not a number of years this time, it's a new addition count, or it's an additional addition going on there, times the original number of book pages. So that's where this is coming from to give me 500 times 1.1, or 1.10 if it helps you to see that. The other thing you can say is this one right here is representing 100% of the book, right? The original 500 pages. This 10 is representing 10%, the additional 10% number of pages. What do you get? How many pages is the an addition? That's right, it's 550 pages. So we get to make a third edition, don't we? So what am I going to do with my third edition? I'm using 550 now because I want the book edition before to increase by 10%, right? So I need the 550 from the last problem, the last part of this problem that is, to then be multiplied by my 1.1. So much of that? 605. So it's not 600, it didn't increase actually 50 pages, it actually increased 5 pages this time, didn't it? All right, how about my fourth edition? All right, so it's 605 to start with, right? 605 times the 1.1. And then Kayla, what'd you get? 665. Okay, so I'm going to need it. So we need a whole number of pages. I really don't care whether you round up or round down. It doesn't matter to me as long as you're getting pretty close. We're okay. So somewhere around 666 pages. So I need to make a new addition, don't I? Now, in the problem, I need to take 666 pages because that's what physically the book number 4 had, multiplied by my 1.1. How many book pages is that? 732. I gotta keep going, right? Sixth book, 732 times my 1.1. I promise we will get to the point where they can't make more books. 806. If you get a different answer, you need to let somebody know. Seventh book, that's my 806 pages. And increase that 10%. What do I get now? Is it 887? Okay, how about my eighth book? 887 times 1.1. 976 pages. And I think if we do the ninth book, obviously we're going to exceed the contractual limit, right? So the question asked it again, how many editions could be published before it reaches the contractual limit? It can actually have 8 published. All right, one last problem in this section. Example 12. Because of a recession, the value of a new house depreciated by 10% each year for 3 years in a row. Then, after that, the next 3 years, it increased by 10% each year. Did the value of the home increase or decrease in 6 years? Explain. Now, the one thing it doesn't give you in this problem is what is the value of the home, right? And because it doesn't give you that, it really means that it must not matter. Are you tracking with me? And if it doesn't matter, that means you can pick what you want. So I'm going to pick a nice, full, wonderful value of $100,000. It's a reasonable amount for a price of a home. There are homes that are that price. So we're going to use $100,000. So the first amount, so the original price of the home, we're going to say was $100,000. Because you see at the end, we're going to get another price. And we just want to compare that price to the first one we picked. Which is why this data was picked. Because of the comparison issue at the end. All right, so there's my original price. So the first year, after the first year, it has decreased by 10%. How do I figure out what that value should be? All right, so just like we did times 1.1 to increase by 10% on the last slide, if we want it to decrease, we're going to multiply it by, in essence, 90%, 0.9. So what is 100,000 times 0.9? It's 90,000, yes. There's a reason I picked 100,000. It's easy to work with. All right, but it's going to do it again, right? After the second year, it decreases another 10%. So I'm going to take my 90,000 and what I'm going to do with it? Times it again by 0.9. What's it going to become? How about 81,000?
That's what I meant.
Okay, that's what I thought. Are we done with the recession? Not in the problem anyway. May not be done with it in real life, but we're not in the problem. All right, either. So, all right, so we had our 81,000, and again, 90%, right? So what's 0.9 of the 81,000? 72,900. So we're up a creek. We borrowed too much money right now and need to sell the house, aren't we? We are. But thankfully in the problem, the next 3 years are better and things go up from here, right? And you might sort of in your mind be thinking, well, I decreased to 10% per year and then I increased to 10% per year. I should end up with the same price of the house. So let's see if that works. So if I take my 72,900, what am I going to do with it now? I'm going to do it now to increase by 10%. I'm going to multiply it by 1.1. That's like what we did on the last slide, right? It's 110% of the previous price. So what is 110? Well, what is 1.1 times 72,900? 80,000 what? 190? Like this?
Yes.
Okay. All right, fifth year. We've got a fifth year where it increases 10% again. So, oops, I need my 80,190 to increase by 1.1. What's that give me? 88,201? 209. Okay. Last year of increase in this particular problem, well, at least the point when we're making this decision, 88,209 increases 10%. So times 1.1. What do we get? 96,000 what? 97,000. What's next? 30. Okay. All right, so first question is, did the value increase or decrease? What did it do? It decreased, right? It decreased. And it would be a good idea to decide how much it decreased by. So I want to show you that. So notice, it started out, our made-up house at 100,000, and it came down to $97,030, right? How much money did we lose in the value of the house? All right, so it decreased by basically 100,000 minus 97,030, which was 2,000 what? $970. But we made up those numbers, didn't we? So it's not really fair to say this house decreased by that because we don't really know that the house was really $100,000 to start with, do we? But we can make it so that it generalizes by taking that $2,970 and dividing it by the original amount that we made up of the house. Does that look familiar? We did that back on that passbook account and that mutual fund account or that money market account slide, right? Which is the amount that something changed by, ours is an increase, how much interest we had. And we divide it by the amount of the account starting out at. And if we do this, what do we find? 2.97%. So it actually decreased by 2.97% over the course of that 6